Alright guys, here we go. Here's what we're talking about today. Section 3.1, which is extrema on an interval. Probably the most important thing you guys learn here, first of all, we're talking about extrema of a function, which will be an extreme maximum minimum. That's one type we can do. The other one we're talking about is an absolute, which is more or less what I call a relative maximum and minimum. We're going to talk about the relative extrema and the critical points, and also how to calculate extrema over a closed and open interval. Now we're not going to get through all these today for this first one, but I at least want us to start seeing what we're talking about. These are main things that we're doing today though, talking about how are these lined up. So make sure you guys, again, we're talking about here section 3.1, extrema on an interval. Okay. Let's take a look at something like this first of all. For what values here does x equal 2x minus 5 equals 0? Well, for this one here, I can add 5. I get 2x equals 5. Divide both sides by 2. X equals 5/2. It's no big deal. Easy peasy lemon squeezy. How about something like this, though? X squared plus 3x plus 2. Let's copy this equation down again. X squared plus 3x plus 2. What I want you to understand here, this is a quadratic. Two ways to do it. One, with the quadratic formula. Don't forget the song. Peter Mangano, sing the song if you're there. Two, we can factor. I'm going to do factoring real quick. I can factor this as x plus 2, x plus 1. So then x plus 2 can equal 0, or x plus 1 can equal 0. So x can be -2, or x can be -1. So that more or less finishes our Algebra 1 lesson for what we're doing. Let's talk about how does this relate to calculus. Extreme of a function. Most important things I want you guys to start to see here. Oh, wrong one. When I talk about the extreme of a function, first of all we're looking at are the minimum and maximum values. That's what we're looking at here. For the extreme of a function, we're looking at minimum and maximum values. We call an extrema point by its x-coordinate. For instance, I wouldn't say you have extrema at 2, 3. I would say instead you have extrema at x equals 3. That might be an extrema. The difference between these, extreme and relative, extreme is the lowest or highest point for the entire function. Something like a parabola would have an extreme. Relative is more in that area. There's a little bit of a hump, but the function might go up or the function might go down more. And we'll look at these in some more detail then. But that's the difference between extreme and relative. The book uses the term absolute. I call it more the relative. We're going to focus more on these, but just so you know, sometimes you do have these as well. All right, take a look at this graph here. It's a nice quadratic. For this one here, this is the lowest point. So again, this one would be an extreme minimum. Right there at that point there. Now here's a question. Again, same function. What's the slope at this point? If I'm looking at the slope of the tangent line here, this is an extreme minimum. This is an extreme minimum. And what I'm curious about is what's the slope here? Well, we can kind of write in a line a little bit, and it'll look kind of like that. Let's see if we can fix that up a little bit. We can make that a little bit more like that. That looks better. So that's kind of what our line looks like. And what we can tell here is that line has an m of 0. So to figure out this value, this x coordinate, what we can do is figure out for what values of x does f of x equal 0. Does the slope of the tangent line equals 0? And the way we can do that is figure out, for this one here, what's f prime of x. Again, here's our original problem. Y equals 2x squared minus 8x. So the derivative will be, give you a little dramatic pause here, 4x minus 8. And we want to figure out where that equals 0. This is why I had you guys doing these kind of problems and this kind of a problem here. 4x minus 8 equals 0. I can add 8 to both sides. 4x equals 8. By both sides by 4. X equals 2. And that coincides here. 1 at 2. At x equals 2, we have an extreme minimum. Now I can look at a problem like this one.
Please call Mr. Piper on extension 203.
That's Mr. Piper needing a custodian. No big deal. Again, these are slightly different ones now. For this one here, this one has a relative maximum and a relative minimum. Here and here, this one would be a relative maximum, and this is a relative minimum, meaning it's not the lowest point. The lowest point, again, is negative infinity, and this is not the highest point. The highest point is positive infinity. But instead, if we only look at that one little area, if we only look right here, that's the highest point. Or if we only look over here, that's the lowest point. That's what I'm talking about there. So that's what I mean by a relative maximum or a relative minimum. But now the question is the same. For what values of x does f prime of x equal 0? Take your original function. Let's figure out f prime of x, which will be 3x squared minus 6x, and we're going to set it equal to 0. These have a common term of 3 and an x, so I can pull that out. 3x times x minus 2 equals 0. So this tells me I have relative points at x equals 0 and x equals 2. X equals 0 and x equals 2. Again, the tie into the derivatives though, it's the extreme or relative maximum minimum occurs if the first derivative equals 0. So we solve for the x value to determine the minimum and maximum values. That's all it is. We're looking for minimum and maximum values here, and that's what we're going to do here. That's our tie-in, again, to the derivatives. And again, Ms. Tartt's going to be able to play this again or pause this if you guys need to see some of these slides again to copy them. All right, that's enough.